This is the fourth and last part of the series of videos in which I want the images and language of the writer's problems to match exactly the images and language of the tax rate problems. So this is a link to part 1. This is a link to part 2. And this is a link to part 3. At the end of part 3, I ended with this equation that was the total cost was equal to the combined rates, which is 1 and 875 thousandths times the price. You take this price and you multiply it by this factor, 1 and 875 thousandths, and you get the total cost. And that is right here. It's 108 and 75/100% of $41 is 1 and 875 thousandths times that $41 is equal to $44.59, the total cost. And we got that from solving the system of equations, and as you work through that algebra, you end up with this equation right here. This is the total cost is equal to that factor times the price. So now you can just take that equation and draw a graph. $35 times this factor is equal to a total cost of $38.06. $41 times that factor is equal to a total cost of $44.59. So just draw a graph that has a little bit larger slope, that has a slope of 1 and 875 thousandths, a little bit larger than a slope of 1. This is a slope of 1. So a graph that has a slope a little bit larger is this graph right here. And so now I can use that graph to read directly what the total cost is. So whatever the cost, whatever the price of the meal is, just read up to that graph and I read over, and that gives me the total cost. That includes the tax. And this goes back to the slope triangles, in which, look at this slope triangle right here. This is that orange side. This is the y-axis, the blue side right here. And this length along the y-axis is 1 and 875 thousandths times longer than this length along the x-axis. That's the slope triangle that we looked at a long time ago. I was having trouble getting the language of the writer's problems, and I just chose the 4 times as fast problem as an example. I was having trouble getting that language to match the tax rate problem. And the reason was that this scale is different. This scale is in minutes, whereas for the tax problem, this scale is dollars and the y-axis is labeled as dollars. So once I switch this scale to be miles and this one miles, then the language starts to match. So I change this to miles. So this was 1 2/10 miles in 30 minutes. So it's 6/10 of a mile in 15 minutes. And then 5, 10, 15 is the same as 2, 4, 6. And then 8, 10, 12 is the same as 20, 25, and 30 minutes. So change the scale. And so now I have miles and miles, and I'm going to figure out a rate that increases this number of miles to the total number of miles along this axis. So now work through the algebra. This equation here has a slope of -4. This equation here has a slope of 1. So combine those rates. This is a +4 combined with a +1 is equal to 5, that 5 parts. And you end up with this equation right here, 500% of 1 2/10 miles, which is the same as 5 times 1 2/10 miles. So set the two equations equal to each other, work through the algebra to solve for x. And in that, you have this equation right here. 5 times the distance is equal to the total distance. That's exactly the same as the tax rate problem, which was 1 and 875 thousandths times the price is equal to the total cost. They are exactly the same. So take any distance from writer number 2's house you're going to multiply by that same factor now. That's 5. 5 times 8/10 gets you up to 4 miles, or 4 times 8/10 means that this portion is 3 2/10 farther. 1, 2, 3, and 2/10 right to here for 8/10 of a mile. So what's happening now is you're shifting distance from rider number 2 at the start. Before, rider number 1 was always fixed at 6 miles away, and we changed the times that they met, but it was always traveling that same 6 miles. But now, to keep the rates the same, we're going to shift distance that number 1 is away from number 2, keep the rates the same, so they meet at different distances. This is exactly the same as the tax problem, where we shift the total cost, and that means that the price that we paid for the meal in the beginning has to shift. And so the distance, the total distance away, which is the same as the total cost, is equal to this factor of 5 times the beginning distance. So number 2's distance in the beginning. So 5 times whatever the distance is for number 2 is going to give you the total distance. That's the same as taking the price and multiplying it by the factor, the tax factor, and that will give you the total cost. So the distance that number 2 is away, 5 times that distance is where number 1 has to start to meet this 1 2/10 miles away. So 5 times 1 2/10 is 6. 5 times 1 is 5. Go up here and over to 5. So now the language and the images match the tax problem. So now when I switch the x-axis back to minutes, the analogy with tax rate makes sense to me. So you're going to combine these slopes. This is 8/50ths and this is 2/50ths. So when you make the shift to the algebra, you set these two expressions equal to each other, you're combining the 2/50ths plus the 8/50ths, and this should be 8/50ths x right here. There should be an x right there. So combine them together, you get 10/50ths. That's the same as 1/5. So the equation becomes 1/5 of the number of minutes is equal to the number of miles. It's because the magnitude in miles, that's 6, is 1/5 the magnitude in minutes. So now if you look at 30 minutes, that's the same as 1 2/10 miles. You go across here to the y-axis. This is 1 2/10 miles, and it's 1/5 of 30 gets you out to the 6 miles. Well, that's the same as 5 times. So there's that multiple or factor of 5. That's the same as 5 times 1 2/10 gets you out to the 6 miles. That's the analogy with the tax rate. And so here, 1/5 of 20 is equal to this 4 miles. But remember that 20 minutes is 8/10 of a mile. Well, 5 times 8/10 of a mile gets you to that same 4 miles. Again, that's the analogy with the tax factor. So now if I graph that equation, the equation is the total distance is equal to the factor, which is 1/5 times the time. So again, the magnitude in distance is 1/5 the magnitude in time. So go out here to 20 minutes. 1/5 of 20 minutes is 4 miles. 1/5 of 20 is 4. It's 4 miles. 1/5 of 30 is 6. So that gets you out to the 6 miles. So now the analogy with tax makes more sense to me.